All right, welcome everybody. Welcome to this new webinar. I hope you can hear me. My name is Stéphane Blanchet. I'm sales manager at Ramen Valves, and today webinar is about our new solution, our new surface hardening solution for valves. So I will be today's speakers along with Frédéric Halbou from SuperExpanite, and we will discuss a lot and provide a lot of information about SuperExpanite treatment. I'm also joined with Lina Passy from Ramel. So all technical things and so on, you can ask if you have any problem and so on. You can use the chat function to write something. The webinar will last around 25 minutes, and you can use, of course, the chat function if you have any question and so on. And of course, at the end of the webinar, we will have around 5 minutes to answer any question. This is recorded, actually, so you will have the opportunity to watch it again or forward it to whoever. It will be available on our YouTube channel. And also it will be provided by PDF after the webinar by email. All right, so let's start. Okay, so this is the agenda for today. So I will make a brief introduction about Ramen Valves, who we are and so on, about our products a little bit, and also why we decided to change from hardcombing and to use another treatment. And then Frédéric will explain everything about SuperExpanite. That will be the main topic of this webinar. And at the end, I will make a brief comparison between SuperExpanite and hardcombing. And of course, at the end, Q&A. So briefly about Ramen Valves, a brief introduction. So the company has been created in 1945. So it's quite an old company. We are located in Stockholm. We have manufacturing sites in Sweden. So we are a Swedish company. We are quite a small company, around 11 employees, and the turnover is around 5 million euros. Okay, and you can see also on the right, this is our main product. This is what we call a ball sector valve. So it's similar to segmented ball valve, if you know better. And of course, the main application is abrasive application. So for example, in pulp and paper, mining, steel plants, wastewater, and so on. And of course, for this kind of application, you need to have a very hard material. So traditionally, we used, and all kind of manufacturer, all valve manufacturer used hardcombing. That's the most common treatment now. So to increase the hardness, because of course, the better the harness, the better it will be for handling abrasive application. But okay, why did we decided to change from something very used, very common that has been proven, hardcombing? Why did we change from hardcombing to SuperExpanite? Well, there are several reasons for that. The main reason, of course, is that there is this REACH committee in Europe that states, so it's a fact, it states that we will have all manufacturing process, all suppliers, all manufacturers and so on will have to limit their hardcombing by 2024. So that's a fact. It means that in 1 year, all manufacturers using hardcombing will have to limit it and use something else. So that's the first thing. So then from this thing, we were thinking that, okay, we can, of course, go the easy way and try to find something very similar with similar chemical component and so on to go the easy way. But Ramen Valves, we always want to stay at the forefront of innovative solution and to try to find, in that case, the most sustainable solution. So we were looking for partners, and we found SuperExpanite, so it's in Denmark, which had reference in other type of industries like automotive, pumps, and so on. Not valves, but okay, we tried. So we tried the SuperExpanite treatment in 2019 in some steel plants in Sweden, and the success was, yeah, it was a success. So the reference worked and so on. So we decided at the end that we will really change from hardcombing to SuperExpanite. So now it has been decided that Ramen Valves from now on will use SuperExpanite instead of hardcombing to increase the hardness of the valves. Right, but now we'll let Frédéric talk about SuperExpanite, and you will have a lot of information about what it is, how it works, and so on. And then we will make a brief comparison with hardcombing.
Thank you.
Yes.
Thank you so much. I'm going to start the presentation here. I guess you can see my screen now.
Yes, we can see it. Yeah.
Great. So first of all, thank you so much to Stefan and to Amins for giving us the opportunity to tell a little bit more about Expedite and the treatment that we offer in the market. I don't have so much time, so it's going to be quite quick, but hopefully you will get enough information that you need. Otherwise, you can contact me or Stefan afterwards, and we will answer your questions. Either he will or I will. So my name is Fredrik Albu. I'm Swedish. I live in the Malmö area. I'm the Nordic Sales Area Manager for Expedite since May of 2022. And previously, I've been working with PVD coatings and nitriding of more conventional steels at Oerlikon Balcers for many years. Very shortly about Expedite, for context, it started as a research project at the Technical University in Copenhagen, or in Denmark, in the early 2000s. And the goal was to find a method to harden stainless steel without compromising the corrosion resistance. That was done by 2009, and in 2010, the technology was commercialized, and well, ever since, it's been a success for us, growing every year. We do have a global presence. I'm not going to go into this, but if any one of you need or to know anything more about where we are and how we can help you locally there, please let us know and we will inform you on that. So what we do is to harden stainless steel. And we harden the stainless steel by a gas-based diffusion process. It's a diffusion. It's not a coating, it's not a layer, and so it's something that we build into the material. This means that it's not prone to delamination or cracking in any way. So on. In order to enter to the material, you need to activate the passive surface, or the chromium oxide layer that's on top of the stainless steel, and which also makes it the stainless steel stainless. And you can do this in several ways. We do it with gas and temperature, and a very environmentally friendly way to do it. And what we form in the surface is something that we call expanded austenite, and that's also where our name comes from, Expedite. We work with all stainless steel alloys, austenitic, ferritic, martensitic, duplex, and also titanium. We also work with other alloys, but I'm not going to go into that right now because that's not the topic. We have 4 standard products or solutions in our portfolio, and I'm going to tell you a little bit about them briefly in the coming slides. Firstly, we have the Expedite high T solution, which is a high temperature solution nitriding process where we diffuse nitrogen into the material. In this process step, that can be used for all stainless steel alloy types, and also as a standalone service for ferritic and martensitic alloys. Is a process where we increase the hardness of the material. Firstly, we'll bring the material back to a kind of a virgin state, but we also increase the surface hardness from around 500 to 1,000 Vickers into the material, into the surface, to a hardness of around 750 Vickers in general. This is actually what it looks like. This is a picture of the hardness profile that we achieve. So from 750 Vickers on top, and then slowly decreasing as the further into the material you go, until you reach the core hardness. So the brighter area, of course, is the diffusion zone. The second part is the Expedite low T process. Low temperature process, where it's a nitrocarburizing process. We can also do pure carburizing, not what we do so much. But something that we can offer. It's also for all the stainless steel alloys. But this is basically where the magic happens, if you will, because this is where we form the extremely hard top layer surface that sticks around 20 microns into the surface of the material. This temperature is a bit lower. The process temperature is a bit lower than the first step, but I'm not gonna stay on the details. This is what it looks like. The hardness profile you see to the left, high hardness on top, around 1200 Vickers as standard, and the diffusion depth is 20 microns as a standard. Again, I want to point out it's not a coating, although it may look like a coating in one of the pictures where you see the N and the C. The reason why it looks like this is because the top layer, the 20 microns on top of the material, is actually more noble than the rest of the material, meaning that this part has been etched with etching liquids, and it etches much slower. So you have quite a difference in height. So the line you see is actually a shadow. So the star of our show and the process that Ramins has chose to focus on is the SuperExpanite treatment, which is actually a combination of the two previous products that I mentioned, the Expanite High T and the Expanite Low T. So where you first do the High T process and then the Low T process. And if you may remember the hardness profile of the High T process, which is not an extremely high hardness, although a very high hardness with a deeper diffusion depth. And on top of that, you put the extremely high hardness with not so much diffusion depth. But these two combined will make the hardness profile look like this. So a high hardness with a gradient decrease of hardness as the further in you go to the material, which actually brings the material to a very ductile. It gives the material high ductility, but also a great load bearing for outer pressure and so on. I forgot to mention in the previous slide in the High T process where we diffuse the nitrogen into the material. That's also one of the states where you bring in sometimes actually increase the corrosion resistance of the material. Yeah. We also do hardening of titanium. There's nothing really we do for Ramins yet. We are in discussion or touched the subject a little bit, but for where titanium is necessary to be hardened, we also do this. That's done in a bit lower temperature, 800 degrees here. And in this instance, we do not diffuse nitrogen into the material, but oxygen. The hardnesses we achieve typically is around 900 Vickers with a diffusion depth of somewhere between 10 and 80 microns, depending on the need for the application. So what we do is we make the surface of the substrate harder. And this can be measured in different ways. A typical way to do this is a pin on disc test, where you reciprocate a pin or a pin on a surface to measure what kind of wear you have after this test is performed. And as you can see, the red line here indicates what happens to an untreated 316 material, where you form a rather deep groove compared to the blue line, which of course then is a SuperExpanite treated 316 part, where the wear is much less. So the hardness in and of itself provides a great abrasive resistance. Another benefit from hardening a surface of a stainless steel is that you will significantly decrease galling, the galling effect. One standardized lab method to measure this is the G98 galling test, where you take a bolt and put it on top of a plate, and then under certain pressure twist it 365 degrees and then measure the outcome of that. And as you can see in the picture to the left, which is a situation with two untreated parts, the galling is rather immediate. Whereas to the right, where you have two treated surfaces against each other, basically nothing happens in terms of galling. And as you can see, you're way above yield strength in one of the trials there, and what you can see, it's a little bit darker on the surface there, but that's actually a wear-in or a polishing of the two surfaces against each other, which in the long term is a good situation if you have a tribo application where you need lower friction and wearing in. Another consequence of the treatment that we have is that it actually, for some alloys, increases the corrosion resistance. For 316, for example, you can see in this graph here, which is a pitting potential increase of 400, I don't know the abbreviation, MB. You can see the blue line is then an untreated part where the corrosion occurs rather instantly. In this test, you increase the potential, and you also see a lot of distortion of the passive layer until it actually breaks through. The green line, which is a SuperExpanite treated part, there's really no distortion until it actually breaks through eventually. But it's really an increase of resistance in this for this test. Salt spray testing is our other tests that we do, and we perform extremely well in those as well. One thing that's very positive for us and for the methods that we use is that we see an increase in demands from the market of sustainable solutions, or that the value chain has the sustainability from actually A to Z all the way through. This survey was performed in 2021, and these numbers are actually rather low compared to this year, compared to what it was in 21. So there is an increase for sustainable solutions, and we are actually happy for that, as the solution we have is sustainable in many ways. It's clean, and it's clean in the sense that the parts that we put into our furnaces, they come out just as clean as they were before. There are no post-cleaning needed whatsoever of the parts. So we cannot really say exactly at this point what we do, but we can say what we don't do. We have or don't have. We have no toxic waste from the process. No chemical baths are used, meaning that we don't have any wastewater to handle or any chemicals to handle and destroy afterwards. The environment for the workers is safe and clean, and the staff, as you can see on the picture here, they don't need any safety gear or whatsoever. The reason why he's wearing gloves is actually to protect the parts, not so much himself. The gases we use are clean, and we use very little of them in the process, and the energy that we use is also very little in order to heat our furnaces. And also the emissions are very, very low, below the Danish standard, actually. So to summarize, what we do is to increase the hardness of the stainless steel surface, which has an effect of the wear resistance, which increases, the galling resistance, which also increases, and also decreases, then I should say, the friction coefficient by a lot. And we doing so, we actually maintain, or in some cases then improve the corrosion resistance. It's a sustainable alternative compared to many other alternatives, especially hard chroming. It's clean, low carbon footprint, no water waste or chemical waste, environmentally compliant, and compliant also with food and medical applications if you're in that business. And it's a excellent alternative if you want to replace hard chrome plating, and also maybe gas or plasma nitriding, as the corrosion resistance is maintained or even improved. Yeah, that was it.
All right, thank you, Fredrik.
Thank
and I
you.
will share again my slide. Right. Okay, but now it's a brief comparison between SuperExpanite and hardening. Here you can see, so it's the last slide of the webinar. So as Frédéric mentioned, SuperExpanite, what you can achieve with SuperExpanite is a harness of, let's say, up to 1,500 vickers. Now, if we compare to hardening can go maybe up to 1,000, 1,100. So just by using SuperExpanite, you can see that it increased already the harness of the base material. And when you want to use a valve in abrasive application, of course, the harder the material is, the better it will be, and the longer lifetime it will provide. That's already a fact. I know in terms of corrosion resistance, and maybe Frédéric, you can correct me if I'm wrong, but SuperExpanite do not affect the base material, right? Right, Frédéric?
Correct.
Yeah. So it means that, of course, when you select a valve, we provide stainless steel, we provide 254 SMO, we provide titanium as well, and this is due to the media, so that it's corrosion resistant. So we don't want to have any treatment that will affect it. If you compare to hardening is a layer that you will put on some parts, for example, the ball sector that you can see on the right of the picture. And this layer may not be compatible with some media, like, for example, sulfuric acid, phosphoric acid, and so on. So you won't be able to use hardening in that case. So at the end, it improves the corrosion resistance, and you can use it more than hardening in that case. And then, of course, as Frédéric mentioned, it improves the galling resistance. So it can provide opportunities for us also, because we can use it in titanium valves where traditionally we use only soft seat to avoid any galling between the metal seat and the titanium ball sector. But with SuperExpanite treatment, we can use metal seat at the end also. So we could use titanium ball sector valve for abrasive application and very corrosive application as well, that we couldn't do before. Maybe something, Frédéric, you can let us know also, does SuperExpanite provide cracks on the surface when you do it?
No, it's something we diffuse into the material. As one of the pictures showed, you can see that it's very dense, but it's not a coating. So if there is a crack, it's because the material itself cracked.
Yeah. That's also a benefit as well, because hardening, you may have crack at the end. Hardening do not like impact. So if you start to have cracks on the hardening, then you will have galling at the end. So you will have damage and so on. And just by, again, having SuperExpanite is another benefit we can provide. So all of this together, we think it will improve the lifetime of the component of the valves compared to hardening. We know also, and we have done it already, we can also treat other parts that previously were not treated, like the body, for example. We can completely treat the complete valve, the body, all parts in contact with the media that before we were not doing. So we can also provide a better solution than that we could before. Yes, and of course, at the end, it has less environmental impact. So it is, we think, the most sustainable treatment there is in the market right now. And we think also that sustainability is a very big important topic in the world right now. So we think that customer should have the opportunity to select sustainable solution. Right. So I think now we are done with the presentation. So I don't know if you have any question related to this. No, you are free to ask your question in the chat function. So it's no for the moment. And again, this will be recorded. It is recorded, so you will have the opportunity to see it again if you miss something. So okay, so we have a question right now. So Roman, we decided that it will not affect the price of the product. So we have a price list, which is actually available on our website, so it's public. So by moving from hardening to SuperExpanite, we decided to make a strategic decision to not affect the pricing of the complete solution as well. Is this process universal for every application? I'm not sure what it means, but of course we will use it as a replacement for hard chroming, and we do not see any limitation to use SuperExpanite instead of hard chroming. That would be actually the opposite. There is application where before we could not use hard chroming, but now we can use SuperExpanite. So to the whole world, I don't know. Actually, the restriction will be in Europe because of the REACH committee, but it may happen also in other parts of the world. Is that I don't know. The presentation will be available by email. Yes, it will be signed after the webinar. Comparison to ceramic, that we have to compare with the ceramic harness that I don't have right now. But the comparison right now is between hard chroming. That's something ramen valves were providing before. We do not provide ceramic coating.
Sorry, if I can answer this question afterwards, so send the question to me then. The questions we can't answer here, so but I can answer that afterwards.
Yeah, no problem. Question for Thomas. Yes, if you have a ball sector that was with that need to be replaced, of course we can provide a new ball sector with SuperExpanite instead of hard chroming, so it's replaceable. Question from Reynold. I don't know if you have seen.
Yeah, it is not a layer. It is actually a part of the part, so it's nothing that you put on top of it.
No.
So it's a diffusion process, so it goes into the material and makes the material hard itself. So there is no tightness to talk about here.
Exactly.
You change the properties. You do not change the material, but you change the properties of the ground material, so that the ground material is hard in itself.
Yeah. Exactly. All right.
Very good questions, I would say.
Yeah. All questions are good.
Yes.
All right, but if there is no question anymore, of course we can end the webinar. You have our contacts in this slide. You have the presentation also. So if you have any other question later on, feel free to contact me or Flick, and we will answer your question. But okay, I hope it was interesting for you guys. And again, any question you need, any information you need further, you can always ask us.
Yes.
Yes. All right. Okay. Then I think we will end the webinar.
Thank you from Sweden.
All right. Thank you. Then we will end the webinar.
Thank you. Bye.
Thank you, everybody. Thank you.